All right, working on this problem with the projectile. Um, just kind of give you a graphical of what's going on here real quick. If we have our x and y axes, the projectile, and this is the time axis, this is the h of t axis. What's happening is that this thing is starting at a height of 10, and it's being thrown straight up and then coming straight back down. But if we reference that off the time, it's going to go and look parabolic. Every one of these points on this parabola are some time, comma, a corresponding height at that time. Okay? So what I'm interested in is to determine the time it takes this projectile to return to the ground. We're looking for that point right there when it hits the ground. Well, that time, comma, h of t is going to be a t, comma, 0. The height has got to be 0. So that's what we're seeing here. So this thing right here is going to be 0. So we take 0 is equal to negative 16 t squared plus 100t plus 10. Now, please understand that the algebra we're about to do doesn't know anything about this being a projectile. Okay? So the algebra that we're going to do is also going to find that point there, because the algebra only knows this to be a parabola. Okay? So we're going to go through the algebra, and it's going to give us these 2 points. We need to distinguish that that one there isn't the one we're looking for. Okay? So we're going to go through this. We're going to say the opposite of b plus or minus square root b squared minus 4ac all over 2a is equal to t. We're going to plug that stuff in. Okay, opposite of b is negative 100 plus then b squared, which is going to be 10,000, minus 4a is negative 16, c is 100, or sorry, 10, all over 2a, which will be negative 32. Okay, now what has been frustrating is that some of us are doing this calculation, right? I'm going to get a highlighter real quick. We're doing this calculation right here incorrectly. A negative times a negative is a positive. Okay, so that's going to give this quantity underneath the radical to be, that's going to be 4 times 16 is 64 times 100 is 640. So it's going to give me 10,640 underneath that radical. And then we're going to divide by negative 32. When we plug this stuff into our calculator, because that's not a really nice number, I think that's 10,640. Grab my calculator real quick. 10,640. It gives me about 103.15. 103 is approximately negative 100 plus or minus 103.1504. And we'll divide that then by negative 32. Okay, hopefully you recognize that that's going to give 2 solutions. One of those solutions, sorry I'm running out of room here, is that t is equal to negative 0.098, and the other one is t is equal to 6.348. Okay, well, time being positive is that one right there, 6.348, is the one we're looking for, because time being negative is going to be this blue point over here that we don't really want. Okay, but again, remember, the math didn't know that, the algebra didn't know that. Okay, when we do this, we are removing ourselves from the physical application, the physical understanding. This math does not know there's a physical application to it. Okay, so you have to be able to do the math and recognize that physical idea. Okay, the next one. we've got something here in quadratic form. The power here is in a 1 to 2 or 2 to 1 relationship, how you look at it with the power of 4. So what I'm going to do is I'm going to let that thing there be u, so u equals x squared. Okay, and then I end up with x squared, or sorry, u squared end up being x squared squared, which is x to the 4th. Okay, so that tells me that x to the 4th right there can be rewritten as u squared minus then 5 x squared is going to be rewritten as u, and minus 36 is equal to 0. My hope is that we could have factored this, so we get u minus 9 and u plus 5. I'm sorry, 4. Multiplying those out, 9 times, or negative 9 times 4 gives me negative 36, and add negative 9 and positive 4 together, I get negative 5. So then I get u minus 9 equals 0, u plus 4 equals 0, so u is equal to 9, and u is equal to negative 4. But remember, u was x squared. I'm going to make that substitution again, get back to x squared equals 9, and x squared equals negative 4. Well, solving for x then, I'll take the square root of both sides, you get x to equal plus or minus radical 9, which evaluates to 3. And here I get x to equal, I'm going to write it this way just so we recognize it, the square root of negative 4. Well, take the I out. Okay, and it should be plus or minus. So I get plus or minus I radical 4. Well, that is the same thing as plus or minus 2i. So there's my two imaginary solutions, and there are two real solutions that I told you should get. Okay. I think it's really hard initially for people to factor this here directly into something like this. U squared minus 9, u squared plus 4. But if you think about it, if you FOIL this, u squared times u squared, or let's just write it, I guess, x instead, because that's what we started with. If we go x squared times x squared, that gives me x to the 4th. Outside times outside gives me plus 4x squared. Inside times inside gives me negative 9x squared. And last times last gives me negative 36. And it does give me x to the 4th minus 5x squared minus 36. But I think it's hard for people to realize that. So make that substitution of u, and it makes the whole process just a little bit easier. This one down here at the bottom, absolute value, what we're saying here is absolute value of something, okay? Regardless of what this expression is, you're saying when I plug a number in and evaluate and take the absolute value, I get something that is negative. Hopefully you know that when you take the absolute value of something, no matter what it is, absolute value of 3 is 3. Absolute value of negative 3 is 3. Absolute value of 5 is 5. Absolute value of negative 5 is 5. No matter what I put in there, the result that I get back over here is always a positive number. Here it's saying you should get a negative number. You should know that that is not possible. Never happens. Absolute value is distance. Something is away from 0. Therefore, distance can never be negative. Some people did this, which is okay. I understand the logic here. They said, I know this rule that we talked about in class, that if that happens, I should be able to say ax plus b equals c, and ax plus b equals the opposite of c. I understand that. You're right. So they did 3x minus 4 equals negative 3. And they said, well, 3x minus 4 is equal to the opposite of 3, so positive 3. And then they solved these. So they got 3x is equal to 1, so x is equal to 1/3. And over here, they got 3x is equal to 7, so x is equal to 7/3. But my argument with you is think about what you're doing. When you plug that 1/3 in, right here, 3 times 1/3 minus 4, take that absolute value. You're telling me that that should equal negative 3. Well, 3 times 1/3 is 1. 1 minus 4 is negative 3. You're telling me that the absolute value of negative 3 should equal negative 3. Well, we know absolute value of negative 3 is 3. So you're telling me then that 3 is equal to negative 3, and that is not true. And you get the same argument when you plug in 7/3. You would get a positive number Okay, you get positive 3 here instead, so that'd be a plus 3. And then again, absolute value, that would be 3. And you'd be telling me 3 is equal to negative 3. That cannot happen. Okay. Another way of viewing of why this doesn't work is to think about a graph. If I think about 3x minus 4, what really happens there, I believe it looks like something like this, maybe. Okay, where we move to the right some distance. And it's going to be, I think, of a distance of 4/3 would be really where that x-intercept ends up being. But negative 3 is going to be that line. Well, we see that the blue absolute value never crosses the red line at negative 3. So because they never intersect, there is no solution, because that's what we're looking for when we solve an equation, is their intersection. Please, please, please watch this video. Make sure if you have any questions, you ask me. We'll continue to work on this stuff and hopefully get better at it.